Hello everyone, welcome to my latest course, that is Introduction to Oracle Multitenant Architecture. Currently we will go through the theoretical part of multi-tenant architecture, and then we will go through the practical aspect. So actually uh, the way I will be proceeding with this is currently I will be discussing the introduction as well as the multi-tenant architecture overview, and then what business problem multi-tenant architecture is trying to resolve. Then we will go through every topic in deep, and we will perform some practical aspect of it as well. This particular video series will take around 4 to 5 days, so keep looking for the latest videos. This one will be 1 or 2 videos which will be covering the brief overview of Oracle multi-tenant architecture. So let's proceed. Yeah, so objective will be what you guys will be learning and will be covering through the lectures. So as per I said already, that we will see to it that what business challenges this multi-tenant architecture is trying to address. We will see the understanding of the workings of multi-tenant architecture at higher level. We will see the benefit of why we will be using the multi-tenant architecture in the first place. So these will be the objectives. Okay, so this particular slide will show you what all different machines and different aspect of machines we used to use before the multi-tenant architecture came into picture. This is what the IT infrastructure, what Oracle used actually to install databases. So let's say that let's see about the resource utilization aspect of it. Let's say that we have 10 servers and we are actually installing Oracle database on those 10 servers. Now, as per the resource requirements, we actually have selected 16 GB. Let's say memory will be 16 GB, CPU will be 4 CPUs, and disk will be 1 terabyte. Let's say all the servers will have the same type of configuration, but the bottom line is not all servers or any of the servers will be using the resource in its full what you can say full utilization. So what we are wasting here is memory, which will be counting it into 160 GB. We are just utilizing 90 GB, as you can see in the picture as well. CPU as well. There are 40 CPUs. Let's say if there are 10 servers, then 40 CPUs. We are just utilizing 20% of it. Disk 10 terabytes. We are just using 5 terabytes. So we are not utilizing databases and as well as the infrastructure to its full capacity. So that is a resource wastage. That is the problem with the resource utilization, what we actually figured during these years. Now let's say about the upgrade time. Again, if we have 10 servers, let's say if each server require 3 hours of patching or upgrading, it will take around 30 hours of total DBA time. If one DBA is performing task on one server, then 30 DBA time, 30 hours of DBA time, which is a lot. And it will take a lot of time to actually upgrade those databases or patch those databases. Third will be the administration time. Let's say we have 10 servers again. Now we will have to perform the database administration activities, as you guys all know. So we will need to do configuration, we have to manage security, we have to manage the optimization and the backup. Now there are 10 DBAs, so it will take around a lot of time and as well as so much amount of DBAs. So actually, let's say we already have 10 DBAs working on this infrastructure. So lot of DBAs, lot of DBA hours. So yeah, administration time will take lot of capacity. Yeah, so as we all saw in the slide that these are all are the negative points of how we performed our administration activities or our IT infrastructure. We never used the IT infrastructure into its full capacity, and then we have to bring in a good amount of DBAs to actually do all these tasks. So we are actually, you can say that we are actually getting impacted by all sides, including resources, including cost and everything. So let's say how multi-tenant architecture is trying to actually solve this problem. So yeah, these were the challenges: underutilization of IT infrastructure, inefficient use of DB resources. Everybody needs to do all these tasks on the different servers. If we have 1500 or 1000 servers in a bigger infrastructure, then it will take a lot of time to actually upgrade, patch, do the administration activities as well as security and compliance. So what is the solution which Oracle Corporation brought in? That is the consolidation. Now, if you guys have a question that we already had consolidation before multi-tenant architecture, so let's see what all consolidation models we have available before 12c. So those consolidation models were virtual machine on physical servers and dedicated database physical servers. As you guys all know that big infrastructure or the mid-size infrastructure, or rather small infrastructure as well, they use VMware virtualization or Citrix virtualization and hypervisors to actually virtualize the server so that actually they can use the resource to its full capacity. Now the advantages in that was that it is simple to implement if you actually segregate files as well as proper resources differently to different virtual machines. So let's say one virtual machine have one database installed and another virtual machine has different database installed. Now you are actually segregating those virtual machine as well as database itself. So regulatory compliance as well as security as well as different aspect of it, it's it's very good. Databases will be isolated and we are actually reducing the infrastructure costs. Let's say we have 32 gig of 32 gig RAM server as well as 1 terabyte of that particular server. We have a hard disk on that server which is 1 terabyte. We can actually kind of partition that particular server into virtual machines. So we can install hypervisor and then we can start 3 or 4 virtual machines according to our requirements. So we can actually divide that particular bottom layer, that is hardware, into 4-5 virtual machine according to whatever we need. The disadvantage in that was there was another layer added. Now that administration is now required, and as we all know, as soon as virtualization layer has been added, there is a lot of issues in network as well as lag as well as IO operations. So it is preferred but not for the critical environment. People would still have preferred to install database separately on the particular server rather than virtual machine is good but not for the critical environment in itself. Now for the database and dedicated database physical server, as we all know, we can create multiple Oracle homes. We can install multiple databases into the physical server. Yeah, it was good that resource utilization, we are kind of installing multiple databases on one physical server, but that is actually not sufficing our need. The thing is that when we start these databases, Oracle still will have a separate SGA for each database. So it's a major advantage, and it's still not fulfilling our needs. So what can be done? So this is multi-tenant architecture which Oracle brought. We are currently talking about 12c, and nothing has changed as such. If you can call it this, if I remember and if I can think of, this is the major change in Oracle database architecture in a decade. And after 12c R2 everything is same, just that small features are changing, but 12c R2 is kind of the base of everything. So that is the best version you can call of. So we are talking about the 12c R2. So now what is happening in multi-tenant architecture? Multi-tenant architecture, what it has is, now if we have infrastructure, let's say hard disk as well as RAM, memory, everything, on top of it it will have a container database. Let's say we install a multi-tenant database. What multi-tenant database will contain? It will contain a container. So this will be a container, this part, sorry about that. Okay, it will have a container, and these ones AP, OE and GL are the pluggable databases. So container database. So what container database will have? Container database will have a CDB root. CDB root will have just have metadata of the database. You will create that metadata of the database. You will create the database we are talking about is pluggable databases. So these red color ones are the pluggable database. And now it won't contain, so this particular gray box will not contain application data. The application data will be in pluggable red colored cylinders, that is pluggable database. These database will only contain application data. So if application team wants to actually connect to the database, they will directly connect to the pluggable database. They won't be connecting to the CDB or CDB root. So again, I'm repeating it again. When we install multi-tenant database, there will be container. Underneath it, there will be a CDB root. That gray color box is CDB root, under which all the pluggable database, the name itself says that all the pluggable database will be plugged in. And all the pluggable database will contain application data. CDB root will not contain application data. It will just contain the metadata and no more than anything. And it will contain common users. And pluggable database will contain application data. All the pluggable databases will think them, or if anyone wants to connect to pluggable databases, they will not feel that they are connecting to any other database. They will just feel as the same way as they would be connecting to a non-CDB. And all application connection will be coming to the pluggable database. I hope I have made it clear. In future, we will see the in-depth picture of this. This particular picture is showing something. So showing you the overview of what I was trying to say. So the overview is consolidation of one or more data into single housing container database. So the gray color box is container database again. And these are the small databases. These are the application databases which are connecting to the pluggable databases. It's like USB, right? It's connecting to computer. It's the same way. If you can analyze or have an analogy of how it looks like or how it feels like, it feels the same way. So eventually when you connect to an PDB and when you shut down, you will fail the same way as you would have shut down the non-CDB databases. Okay, moving on. What are the advantages of it? Why Oracle has brought CDB and PDB and container database, rather multi-tenant architecture? So it actually has a big advantages. What advantage it has is it actually addresses the consolidation challenges. What consolidation challenges? So resource utilization and DBA resource cost. The thing is that when we used to use VMware virtualization or install multiple databases on one server, the problem was that there would have been, for every database there would have been one SGA, right, started up, and would have taken a chunk of memory from the RAM. But in multi-tenant architecture, there will be a common SGA for the root as well as the pluggable database. So let's say there are three applications who wants to create their database to deploy their application code. They can actually have a separate database, and all those databases will be plugged into the common container database, CDB database. And now eventually in future, if DBAs wants to install patches or take backups or upgrade the database, all the pluggable database with the CDB databases will be upgraded with it. And when you actually check the SGA in the memory, only one SGA will be started for all three of them. So it's like consolidation, and it's not wasting memory at all, and it's utilizing the memory. And one more important point, that one container database will have one CDB root and no more than that. Okay. Now if you have, so second point is, if you have an application database which is running on non-CDB, if you want to migrate into the multi-tenant databases, then you don't need to change your application code. You can just migrate into the PDB and everything will be same. So it's a easy migration. Now tenant isolation. So now that's what I said before, that if you have multiple applications, those applications are critical applications. They don't want an application team, if they have a compliance, like let's say there's SOX or HIPAA type of compliances, where they want their data to be segregated from, if there are multiple databases, right, for the compliance reason itself. So yes, so whoever actually goes into and logs into the pluggable database, they will actually not know that if there is another pluggable databases exist. If the users are available in one pluggable database, let's say PDB1, those users won't be available in the PDB2. So it's a complete isolation. So it's called tenant isolation. You can, as I already said, easy moving and cloning of the data into the database or schema objects. Now in 12.2, this is the biggest change, that is point in time recovery at the PDB level. In 12.1, there was a big issue. We will talk about it, of shared undo and local undo. But in 12.1, there was shared undo. There was the problem that if you want to do a point in time recovery of specific database, then you cannot actually do it, because the thing is that, because the undo table and undo table space was common, and for that reason, if you want to actually do a point in time, complete CDB has to do that particular process, which you will not want. So it's not like a kind of isolation. In 12.2, there is a new feature, that is point in time recovery at PDB level. Why is that? Because we now have a local undo management as well. So we can do point in time of, let's say we have PDB1, If you want to do point in time recovery of PDB1, then you can do it, because there is undo table space sitting in there locally. And now you can manage the databases physically as well. Easier management of that. If you have, let's say, if you have a huge resource in specific server, like let's say 160 gig of RAM kind of server, right, where 10 terabytes of hard disk is sitting. Now you can create multiple containers as well, and you can house multiple pluggable databases on those containers, right, and kind of isolating the environment itself. I hope i hope you guys got some overview of what I was trying to make you understand about the overview of multi-tenant architecture. We are going to see multi-tenant architecture and diagram in the complete detail. This was just an overview of how it looks like, what business changes happened, and what business challenges multi-tenant architecture was trying to solve. Thank you very much. I'll come up with the second part of this video, and we will then discuss 12.1 and 12.2 differences, and then after that we'll start looking into detail of every topics. Thank you very much for attending.